Today, I'm going to show you how to use Gaussian elimination to solve the system of equations here. The first step in solving a system is to construct an augmented matrix for the system. To do this, you just use the coefficients to construct the matrix. 3, -1, 1, 2, and then 2 and 10. So here's my augmented matrix. And then we're going to use elementary row operations to transform the coefficient columns into columns that form an identity matrix. This is called the reduced row echelon form of an augmented matrix. So the identity matrix can be formed, and then the resulting constants will represent the unique solution to the system. So the first step is to interchange rows 1 and 2. So we're going to switch rows 1 and 2. So the result would be 1, 2, 10, and then 3, -1, and 2. So I'm going to call this, I'm going to use this symbol here. Row 1, and then interchange row 2. Okay, so now I want to make this a 0. So if I make this row 1 a -3 and I add it to 3 and replace the second row with that result, then this would be a 0. So my next step is to multiply row 1 by -3 and then replace row 2 with the sum of row 1 and row 2. So if I multiply row 1 by -3, so the notation that I'm going to use for this is -3 times row 1, add to row 2, and then I'm going to replace that sum in row 2. Okay, so let's do, so 1 times -3 is -3, -3 plus 3 is 0. -3 times 2 is -6, -6 plus -1 is -7, and -3 times 10 is -30, and -30 plus 2 is -28. Okay, so row 1 stays the same. Okay, now I want to make this -7 a 1. So that means I must divide row 2 by -7. And I'm going, or multiply row 2 by -1/7. That would also work. So the notation that I'm going to use this is -1/7 times row 2. So the result would be row 1 stays the same, but row 2 would be 0, 1, and 4. So the next thing I want to do in row 1, I need to turn that 2 into a 0. So if I multiply row 2 by -2 and add it to row 1 and replace the sum in row 1, I'll get my result. So the notation that I'm going to use for this is -2 times row 2 plus, I'm going to add it to row 1, and I'm going to place that result in row 1. So let's do that. -2 times 0, 0 plus 1 is 1. -2 times 1 is -2. -2 plus 2 is 0. -2 times 4 is -8. -8 plus 10 is 2. And row 2 stays the same. And now, if you notice, we have the identity matrix here on the left. and we have these constants on the right, and these are your solutions for your systems of equations. So this represents your x sub 1, and the second row is the solution for x sub 2. So x sub 1 is 2, and x sub 2 is